Hello and welcome to Tonight at 8 from the RSGB. With such sophisticated radio equipment on the market nowadays, it's easy to feel that it's no longer possible to make something yourself which can do justice in the modern shack. But as our two presenters will show, the art of construction is very much alive, and it's perfectly possible to embrace the availability of relatively cheap components and test gear to make some wonderful pieces of equipment. With that added unique feeling that you made it yourself. Later in the programme, we'll meet constructor Pete Juliano, N6QW, in Southern California, who will give us an insight into his world of construction and where he will explain how he creates his own software-defined radios. But first we meet Steve Hartley, G0FUW, an avid constructor for nearly 40 years and now chairman of the GQRP Club, which is dedicated to sharing members' ideas to encourage others to make things for themselves. Hello, Steve.
Good evening, David.
Good to see you. What are you going to be bringing us tonight?
Well, I'm going to give you the amateur sort of view on why we build radios and a little bit about how we build them and show you some examples of things that you can do for yourself.
Excellent. Well, we're really looking forward to it and to Pete later on. But before the presentation, a reminder that if you're watching this on Monday the 11th of January, then this is live and you can ask questions and add comments on either BATC or YouTube at any time during the presentation or straight afterwards. Please include your first name and call sign if you have one within the message. And please note that you can make your video screen fill your screen on most devices, usually by double clicking on the picture or pressing the full screen button. But now it's time for the first part of our presentation, so it's back to you, Steve.
Thank you, David. Well, I guess the first thing I need to say is that why am I here presenting this evening on this particular topic? And as the strapline goes, I've been building radios since 1983, and that was actually before I was even licensed. And it was a revelation to me that you could build your own radios, and I've thoroughly enjoyed it. I've encouraged many other people to learn about the joys of homebrew, leading build-a-thons here in Bath, a number of radio clubs, conventions, and the biggest one I ever did was at YOTA 2017 when we had 90 youngsters building radio kits, but more of that later. I've served on a number of RSGB committees and the board, and now I'm very proud to be the chairman of the GQRP Club, and we have a strong following of home brewers who love to build their own equipment. Not all QRP, has to be said, but mainly low-powered. And whilst I'm a great advocate of homebrew, I do have commercial gear. I'm not exclusively homebrew, and the two are not mutually exclusive. You can mix and match, which is a bit of a theme for my talk this evening. And despite rumours to the contrary, I don't roll my own coax. I have made balance feeder, but not coax. For some reason, my slideshow doesn't go advance. Here we go. So this is my agenda for the evening. 3 questions. Why do people still do homebrew? Because a lot of people think that's it's gone and nobody does it anymore. Why would you do it? And that's a question I often get asked. Why on earth do you do this? And then look at how you can do it. There's a number of different techniques and things you can use. So we'll have a look at some of those. And then I'll, throughout the presentation, we'll see some examples of things that I've built in the last 30 odd years. So the first question, do people still homebrew? And the answer is an emphatic yes. And the picture, we start there, you can see there's some 16 GQRP Club members at the last convention we were allowed to have in 2019. All building a kit that we put together for the event, and I think we just about finished in time to hit last orders in the bar. Everybody was having such a good time. It certainly filled the evening, and a great time was had by all. When I was doing the YOTA 2017 project, we asked Hans Summers at QRP Labs to if he could put a simple kit together for us. What he eventually delivered was way beyond our expectations, a very complex bit of kit that the youngsters built it and used it all within the week of YOTA. And since then, Hans gone on to sell over 12,000 kits for the QCX, as it became known. So 12,000 kits in 3 years is some going. And I have to say, I don't think any of us thought it was ever going to be that popular. The kit's moved on, and it's now available in a mini version that you can slip into your pocket, which is set to become everybody's popular, I'm sure. I'm chairman of the QRP Club. We have a sales department. Graham G0FUW is our sales department, and he sells thousands of components and kits and project books. He's down to the post box every day. He sent me a message today. He'd sent off another batch of orders today. So I think the conclusion from all of that is that there are lots of people other than me and Pete that still build their own radios. Either that, or they've got some great stock rooms somewhere. So why would you do it? There are a number of reasons, but I came to Homebrew because of the cost. I distinctly remember going into an amateur radio shop about 1982, thinking about getting into the hobby and asking, how much is this Yaesu FT290? And the guy said, oh, that's an easy answer. It's £290. And at that time, I was earning about £40 a week. So it was way beyond my expectations and certainly anything I could afford. And in those days, credit wasn't quite so easy to come by, so it wasn't a case of flash the plastic and walk away with it. And the disapproving look from the then Mrs. Hartley certainly told me I was not going to be going into amateur radio with a commercial radio. And then May 1983, happened to be away for the weekend, picked up a copy of Practical Wireless, and there was an article in there by one Reverend George Dobbs, G3RJV. And I read that article, and it convinced me that I could build my own radios. I'd never done it before, but there was enough encouragement and friendly help in the article that said, yeah, you can do this. And with a bit of help from a local amateur, I started to build my own gear, and the rest, they say, is history. Cost isn't quite so much an issue these days with cheap imports from the Far East. You can pick up a 2-meter handheld for certainly less than you could build a radio kit for. But the sense of achievement when you build something yourself and use it is immense. And the biggest thing I've got on here, the smallest word, is fun. It's actually enjoyable to do this. The picture of the young lad on the slide there, this was from an event we ran at Bletchley Park for British Science Week, just before lockdown, actually, the first lockdown. And that young lad had never done any soldering, he'd never built any electronics before, but he sat there, built the kit, tested it, and the look of joy on his face at the end of it was just unbelievable. He clearly enjoyed it. And his dad said he'd never seen him concentrate on anything for as long in all his life. So for some people, it's the thing to do. And some of us are afflicted by a thing called the knack. And if you're afflicted by the knack, you just have to build radios. It's just the law. You have to do it. And if you don't know what the knack is, just go and search on YouTube after the presentation. Dilbert has the knack. Just remember that. Watch it, look and learn. And if you recognize anybody in there, or yourself perhaps, you have the knack. So where do we start? You want to build some radios. There's basically 2 ways into this. One is to build kits. The other is to build your radios from scratch. Both are perfectly acceptable ways in, but some are more accessible than others. We'll come back to that in a moment. And I mentioned before about mixing and matching. Perfectly acceptable and sensible in some ways to mix commercial and homebrew, and also to mix kits and scratch-built equipment. And you'll see shortly some examples of how that works. But I don't think there are many people who've got a shack that's 100% homebrew or 100% commercial. There's usually a mix of the 2 somewhere along the line anyway. And just in case anybody's interested, the picture there, that's the original QCX. That one's on 20 meters. Absolutely fantastic bit of kit. And yeah, I think I said at the time, it's easier to say what it doesn't do rather than what it does do. And I think all it doesn't do is SSB. It certainly does Morse, and all the test equipment is built in and so on. So a great little kit. Let's have a look at some kits or the benefits of kit building. And the first thing is it should give you a high degree of confidence that when you've finished what you're building, it will actually work. Because the designers of kits or the producers of kits, they put a lot of time and effort into making sure that the design is repeatable, that the components they've provided are of the right specification, and so on and so forth. And when you buy the kit, you generally get all the parts you need. So you don't need to go looking for other things from other suppliers. You make the one order, you get the kit, and you get everything that you need. A lot of the suppliers will also provide an after-sales support. So if you build it and it doesn't do what it's supposed to do first time, they either got a telephone helpline or you can exchange emails. Some of them will even sort of return the kit for a few pounds. They'll sort it out for you if there's a problem. My experience is most problems are perhaps dodgy soldering, maybe a dry joint here or there. Fairly quick and easy to resolve if you know what you're looking for. I don't think it's an advantage or disadvantage, but a lot of people say kit building is like painting by numbers. But if you're learning to paint, then painting by numbers is actually a good way to learn. You can get your skills going with the brush strokes and then develop to paint your own things later. And kit building is a bit like that. You can build the kit, you know it's going to work, you get it sorted, and once you've got the confidence, then you can start moving on to adapt them, modify them, use them with other equipment. The downside, I guess, of a kit is that you haven't got the flexibility that you have with starting from scratch. Whatever the kit designer provides is what you get. So if it's an 80-meter receiver, it will only receive on 80 meters. But as I say, when you're starting, that's not a bad thing. Excuse me. Now, a lot of people think that kits are a thing of the past and you can't find them anywhere. I've seen a number of posts saying it's very difficult to find kits these days. And certainly when we all had a high street store, the Maplins of this world or Radio Shack in the US, you could buy kits from there on the high street. It's quite easy just to wander down and pick one up. I'm not aware of any shops now that sell them on the high street, but certainly you can get them by mail order. And here are some of the suppliers that I know of. I'm not particularly endorsing these. I'm just saying these are the people that I know of and I've done business with. Walford Electronics in the UK, they do a range of kits starting from the really simple sort of basic receivers up to some fairly advanced transceivers and test equipment and so on. And Tim very much focuses on the electronics designs and leaves you to do the mechanics and box things up. And the picture top right on the slide is one of his kits. That's a double sideband transceiver, puts out about 2 or 3 watts, and it works. It's an easy and quick way to get on the bands. Kanga UK have been going around for quite a long time now. The Dennis at Kanga prides himself on providing kits that sort of move with the time. So he's moving into surface mount construction, which is nothing to be frightened of. It's different, but if you approach it with the right mindset, it's actually quite good to do. And Dennis has got some great kits, just dummy loads using surface mount resistors. He's got a receiver, he's got test equipment, all sorts of things. He's got conventional stuff as well, basic transmitters and so on. And the watt meter, you can see, that's one of his kits. Fantastic bit of kit. I don't think it's in production at the moment, but really accurate and really robust bit of kit. I mentioned QRP Labs already. Hans Summers does a range of whisper beacons, the QCX kits that we talked about, but also power amplifiers and VFOs, and Shack Clock even is one of his kits, often based around a microprocessor, which is very useful. I missed out Spectrum Communications. You mustn't do that. They don't endorse it. They don't tend to provide kits complete as such. They tend to build building blocks. So you might buy a crystal filter from them, or a VFO, and do that mix and matching that I talked about before. What they do produce some very good VHF transverters, which have got a good reputation in the VHF community. So a bit of variety there. It's not all HF. Some people think homebrew is just for HF. It's certainly not the case. The bottom kit on the slide is a bit different. That comes from HF Signals over in India. And that kit will provide you with a multi-band SSB transceiver. I think it's about 10 watts output, all for less than £200. It's microprocessor driven, absolutely fantastic kit. It uses very little soldering with that. It's more of a plug and play assembly sort of construction. So I think there's a review in Radcom not that long ago about somebody who'd done this with his daughter, and said it was ideal as a starter kit. And I know people who've done this and they've worked the world with it. It's a really, really good kit. And I've included, with a nod to Pete and people in the States, there's a group of guys over there, the QRP guys, and they do all sorts of kits of antenna tuners and receivers and transmitters, and a good bunch of guys. They've got a great website, lots of information on there. I'm not sure about import duty bringing it to the UK these days, but the kits look very good, and the designers have got great reputation. So again, you can buy with confidence. Moving on to the scratch build, which is it's a bit more extreme than kit building. There's a greater uncertainty involved because you're basically starting with a blank piece of paper. It is definitely not painting by numbers or plug and play. And you should expect problems. That's the fun bit, solving the problems, trying to get down into the weeds and find out why something isn't working. You actually learn a lot more from doing that than if it works first time. So you need to do some research, read books, surf the net, do whatever your preferred option is. And you'll need to go shopping. And quite often you'll need to use a number of suppliers. You can't just go to one place, buy all your bits, and you've got your kit. Quite often you need to know where to go. And I tend to use a number of suppliers, some big, some small. CPC Farnell were very good. They've sort of dropped off a little bit recently. They've reduced their sort of lines, but really good supply chain. Rapid Electronics, they supply a lot of educational material, and they're a good company. Mauser UK, I've done some business with them recently with ferrites and things. Good, again, a good company. But some of the smaller suppliers have got really good services. So Bowood Electronics up in the Midlands, great company, got a great website, hasn't got a massive range of things, but if he's got them in stock, you'll have them in a couple of days. Similarly, JAB Electronics, a company I've used for years, really good amateur radio friendly supplier. And of course, the GQRP Club, if you're a member of the club, you can use the club sales, and we've got components and kits and all sorts of things. So, but they're my main sources. The benefit of scratch building is that you've got total flexibility. You can build whatever you like. If you want to include upper sideband and lower sideband, you can. If you just want to do upper sideband, then you do that. If you want to make it single band, you can. Multi-band, you really have got the flexibility to design what you want and then find a solution to it. And there's a lot more learning involved in that, particularly, as I say, when it goes wrong, because fixing the problems really gives you a more research to do, but you find out things, and often that's where the gems come out the woodwork. This particular slide, picture on the slide, is a balance modulator, and that's one of the first things I built to get my voice onto HF. It came from a book called Solid State Design for the Radio Amateur, which, if you can find a copy, is worth the amount of power it says it will, because it's been tried and tested. And this one produces about 10 watts across the HF spectrum, and does a pretty good job, up to 50 megs as far as I'm aware. But there are no rules. When you're kit building, you can decide what you want to do. If you want to put a commercial radio into a homebrewed amplifier, that's your business. If you want to add an SDR receiver to an old general coverage receiver, then you can. You know, it gives you a lot of flexibility and a lot of enjoyment, that's for sure. So how do we do it? Many newcomers think you have to have a huge workshop full of equipment and have all sorts of test equipment and access to all sorts of components and things. And then you get some of the older hands who will confuse the hell out of people by talking about spurious emissions and intercept points, phase noise, presence of audio, and so on and so forth. I lasted for many, many years with nothing more than a multimeter, an RF probe, and a receiver. If you can hear the signals that are coming out and it sounds okay, it probably is. And if you're a few hertz off frequency, most of the time that really doesn't matter. Tools, basic soldering iron, side cutters, some pliers, a couple of screwdrivers maybe, and probably just as important, a desoldering pump for when you do make mistakes, because you will. Everybody does, and you need to be able to get the components out and rework the circuit. All part of the fun. And of course, you need somewhere to work. I joke about having a workshop, but if you've got a desk in a sort of home office, that's fine. I know some people that use a tea tray, and they bring that out every time with their sort of kit on it, do some work on it, and then put the tea tray away in the cupboard, and that's their workshop. You don't need all the gear in the world. It really doesn't matter. It helps if you've got an oscilloscope and a spectrum analyzer and a VNA and all these things, but you can gather those over the years, and you get yourself going and see if you enjoy it before you start investing on the big gear. So on to some techniques about how you actually put these things together. The first one is pretty obvious: a printed circuit board. Most of the kits you buy will come with a printed circuit board. Most of them have got the parts marked out on a mat. You can see that one on the slide there. The coils, the capacitors, the resistors, where to put them. Components go on one side of the board. You solder on the rear side. Copper tracks join them up, and Bob's your uncle. It's that easy. Hence the reference to painting by numbers. It's pretty straightforward. It doesn't mean it's guaranteed to work, but it gives you a pretty good chance that it will. You can make your own printed circuit boards, and I do that quite often. It can be a messy business because there's some various chemicals involved, and if you turn the sink brown, it doesn't go down well with your partners or parents if you're a youngster. But I'll show you some techniques that don't need that approach, so you can still produce a decent kit without causing any problems at home. Now, this next technique, you can see why it gets its name. It's pretty ugly, but it's very effective. And the idea is you get a piece of copper board, you solder any grounded components to the copper board, and then they support the non-grounded components. And I say it looks pretty ugly, but once it's working, and you put it inside the box, nobody knows what it looks like. But it gives you access to the components if you want to change something, if you want to modify it. It's a very flexible way of working. And cheap as chips as well. Now, I don't know what they call this in America, stripboard or things. In the UK, we call it Veraboard, because I think that's a proprietary brand. There are all sorts of others knocking about on the auction sites these days. But one of my favourite quotes from George G0FUW was about Veraboard. And he said that some people swear by it, others swear at it. And I have to say, I tend to fall into the latter category. It's ever so easy to bridge across those copper tracks, and it takes some finding if it's just a tiny bit of solder. And if you're mapping something out for the first time, I find I get very disorientated flipping the board over. But I do use it. It's very handy if you've got multi-pin devices like the Arduino Nano. I find that Veraboard's very useful for soldering that and connecting wires and things. So it has its uses. And again, no chemicals involved. A lot of people build with squares. And there are all sorts of names for this. Some people call it the Manhattan style, because the squares of connecting board that you glue onto the copper board form sort of avenues and streets like the city of Manhattan, I guess. But the idea is these squares that you stick on there, you use those to connect. And it's almost like a refined version of ugly. It's not overly pretty to look at, but again, a very effective way of working and very flexible because you can change things very quickly. Drew Diamond, VK3XU, he calls it paddy board construction because he cuts these pads from bits of printed circuit boards. So the pads and the boards becomes paddy board. The ones I've used here come ready-made. They're on a big sheet and you break off however many you need. And they're called Me Squares. They come from QRP Me. Rex over in the States gets these made, and I find them really useful. You can knock up a circuit like this very quickly. It's a bit of super glue to stick them down, and the circuit grows as you build it. Someone who may be about to speak has got a very fancy CNC milling machine that cuts squares for him, so you may get to see some of that in a wee while. The final method which I've used, I really, really like this. It's probably my favorite way of building things, and it's called top ground plane because you use the copper board with the copper on top as a ground plane, hence its name. And any components that are grounded, you can see on the photo there, some of them are soldered to the copper. The leads that aren't grounded go through countersunk holes, and they're connected up on the rear side, point to point, to make the circuit. So it looks pretty much like a printed circuit board from the top, and it works really well. Again, quite flexible if you need to change something. And because you've got this big ground plane, it's actually very good at radio frequency construction, and I use that a lot. Now, if you've made the circuits, what do you do about boxing it up? And a lot of people shy away from this side of the sort of metalworking side of homebrew. This is my technique. I'm not saying it's the best in the world or the only way, certainly, but this is the way I do it. I buy pre-formed boxes most of the time, and then mark it out on graph paper. So you make sure that all the components are spaced out. They've got room to fit on the panel. Then you drill out the holes, cut out any slots and file them flat, and you end up with something that looks a bit like that. And then a bit of spray paint. I use undercoat from the car industry, a nice grey colour. Rub down letters to do the labelling, and then a clear lacquer coat just to protect it. And that is my Vitx20, which is a bidirectional transceiver for 20 meters. Puts out about 3 watts, and I thoroughly enjoy using that. It's a great kit. What you can also see on there is the digital dial. That comes from a company called Cumbria Designs, who sadly are no longer trading, but they produced a very good frequency counter, which I used. And you can't see it, but inside there's an AGC board from Wolford Electronics. So this is a prime example of the mix and match approach. You know, I built the transceiver and then added a few bits and bells and whistles from the commercial world. So just a few more examples of things I've made earlier. This is the transceiver that started it all off for me. The PW7 came from Practical Wireless. It's a 7 megahertz CW transceiver, a direct conversion receiver, and a little QRP transmitter. And it puts out about, I don't know, 2 watts or something like that. And in the 40 years nearly that I've had that radio, I've made many contacts with it and continue to use it from time to time. Might even get around to finishing the dial at some point. You see, there's no actual numbers on it, but I'll get there. Excuse me. The Vitx20, you've seen the outside of it. This is what the inside looks like. It uses that top ground plane construction method that I talked about. You can see there's a crystal filter at the back and a mixer and big variable capacitor. I think that's the carrier oscillator on the bottom right. Again, I had great fun with that, worked the States with it. Actually, when I worked the first contact I had with it, it was sitting on the bench, not boxed up. And I worked a guy over in Maine, Great report from that, and the QSL card a few days later through the post, which was fantastic. And thankfully, it worked when I boxed it up as well, which isn't always the case. When we did the build-a-thons, we tried using our own printed circuit boards, but Mike, who used to help me, G3VTO, point blank refused to do any more hole drilling. It was driving him crazy. So we moved over to use kits, and this is one that we used. Came from Tim Walford's catalogue, and it's a 20-meter super het receiver at the right-hand side, and we did that for a build-a-thon. And then the guys had the option of adding on the pre-CB at the back, which was the transmitter. And again, that puts out about 3 watts of SSB. I think I've worked 30 countries with mine before it went on the shelf for something else. But a nice little kit, and so because it was well designed, it was very repeatable. And last but not least, this is what's currently on my bench, designed by N6QW. And it's called the Simple SSB transceiver. I won't steal his thunder in case he's going to talk about it later, but this one works on 17 meters, and it's receiving very well. It transmits okay, but I've got to connect it together to make it into a transceiver, and of course box it up. So that's what I'm currently working on. But before I hand it back to David and on to Pete, here's just a few tips of where you can go to get more information. I'd get shot if I didn't mention the RSGB bookshop and an RSGB presentation. And 3 titles there, which I think are really good ones to start with. The bottom one, 50 projects for the radio amateur, does what it said on the tin, full of little projects that you can build. You may have to go hunting for the bits, but good designs. The top one, Eamon Skelton's Homebrew Cookbook. Anything by Eamon Skelton is worth reading. The guy's a font of knowledge when it comes to homebrew, and his designs are very good and very what's the word? Dependable. That's the word I was looking for. He does some good stuff. And the QRP scrapbook is full of QRP Club archive material, sort of a best of, if you like, compilation book. Certainly well worth having on the shelf. If you go to the GQRP Club sales, we've got 4 project books by Drew Diamond, and again, great designs. Everything I've built from those book works first time, and really good designs. And if you want to find, we have this magazine called Sprat. It comes out 4 times a year. Shameless advert. £6 will get you membership of the club, and you get 4 journals every year, full of ideas and circuits and designs. And you can get the archive of 185 of those journals, either on a stick, memory stick, or a DVD. And of course, the kit suppliers I've mentioned, if you contact them, they will give you all sorts of information, and based on your needs and your experience, they'll advise you what to tackle. And if all else fails, my email address is on the slide. Feel free to get in contact. I'll be more than happy to answer any questions you might have. And with that, I will pass it back to David.
Thank you very much, Steve. And just a reminder, if you could stop sharing your screen, then we can bring Pete in as well. Steve, thank you very much. And as Steve said, I mean, just to prove it, this is not a plant. This is a book that I have at home. 50 Projects Radio Amateur is really good. And as Steve said as well, because he's probably too modest to promote it too much, of being the chairman of it, but the GQRP Club at £6 a year is a bargain. So if this is inspiring you to do anything, then those things are worth looking out for. Anyway, thank you very much for all those points about hardware and electronics, Steve. We've seen all the hardware now, but the electronic circuitry is just part of it, because of course the 21st century radio amateur can also make good use of software in their construction projects. So joining us to show how we can embrace computer technology is Pete Juliano, N6QW, live from Los Angeles. Hello, Pete.
Hey, David. How are you?
We're good, thank you.
Greetings from the left coast.
Yes.
where it's just a little afternoon. But anyway, we want to say hello to Steve also, and to the main operator there, Tammy. Hi, Tammy. I'll try to pace myself to tell you when to change the slides. But today I want to talk about software-defined radios, and I think this is kind of a fascinating subject that I was reflecting back to when I first got started in this hobby. And in the early 1950s, I got my first CK722 transistor. I built my first solid-state circuit about 1954. So a lot has changed in our hobby since that time. So if you start bringing up the slides, Tammy, we'll be ready to launch. Homebrew SDR, why do it? And what you're looking at there is a picture of a Homebrew SDR transceiver that I built here just a few months ago, and we're going to go into the detail. But first, I'd like to thank the Radio Society of Great Britain for allowing me to present here today. And my wife wants to thank you too, because we've been at home a lot for the last 10 months. And so this forced me to comb my hair, shave, put on a shirt, something other than has food stains on it. So indeed, she's happy that I did present today, because it got me a chance to get spiffed up a bit. Next slide, please. Okay, we're going to talk about Homebrew SDR, why do it? And when you look at this, you say, now, is that a pile of junk, or is that a working SDR? And the first question comes around, well, there's no front panel. There's no knobs. There's no controls. How can that thing work? Next slide. Well, that pile of junk can do this, because we trade in the knobs and the control panel, the knobs in the front panel to a control panel. And what you're looking at right there, that pile of junk is showing 192 kilohertz of 40 meters. And up above, we have the spectrum, and down below is the waterfall. And the control panel gives you an infinite amount of controls, and that's all embedded in the computer. You can change modes, you can change bandwidth, you can tune the radio, you have an opportunity to add a notch filter or noise blanker, you can add AGC. You just have almost an infinite amount of control over what you're doing. Next slide. So why do we do it? And the simple answer is there's so many features and benefits to be able to use a software-defined radio, because there's so many more possibilities embedded in the software. And a lot of these deal with signal handling, the availability of filters. You know, typically the old sideband rig that had just a single crystal filter, you were stuck with one bandwidth. Or it might have a CW filter in it, but that was about it. And so many of the radios do not have all the multi-mode features such as you would have with FM or digital or CW upper, CW lower, upper and lower sideband. Just so many possibilities. Then the other thing is the digital experience. And of course, the new wave with the FT8 and Whisper. And I look to those digital modes as actually tools. As a matter of fact, I'll frequently put a radio on Whisper after I've made an antenna change and let it run for about a week. And then I can look at the data after a week, and it really tells me a lot about my antenna. What am I hearing? What am I not hearing? So these digital modes, aside from just the contact aspect, can be used as a tool in the shack. And I think the key thing is that there's a change in the software, not necessarily a change in the hardware. If you want to upgrade something, there are frequently software upgrades that allow you to do different things, like the AGC just doesn't work real right, so you get a new download and boom, it's fixed. So you don't have to take a soldering iron there and change resistors and capacitors, change time constants. The other thing is the availability of low-cost technology. It is absolutely stunning, the amount of hardware that you can buy for so few dollars. I like to describe it this way. You can have a fully functional digital VFO with a display and encoder, and you won't spend more than $20. I don't know how many pounds that is, but it's not more than about $20. But I think also the important factor is the learning journey. To work with the software-defined radios, you got to spend a little time doing some research, getting up to speed, understanding about how the software-defined radio works, and how you can use it to the maximum benefit. Next slide. Now, here's a key feature and benefit, and this has to do with how much you're hearing. Now, the top piece of equipment, for those of you who have a keen eye, that's a KW Atlanta 2000, which was built in the UK. And boy, I'd love to get my hands on one of those. But even as good as it was, you're only looking at about maybe 2.5 kilohertz. Down below that is a flex radio, and it can look at megahertz worth of slices. 30, 40 megahertz, so you can see the whole band. And notice it has no knobs. It's all done with the computer. So the principal benefit is the fact that you can look so much more at the band. And that's kind of key, because what I frequently do now is I'll turn on my SDR radio and I'll look at the display. Just the other day, I looked on 17 meters and I didn't see any sideband signals, yet FT8 was going through the roof. So that told me the band was open, just no one thought the band was open, so they weren't calling CQ. A few seconds later, calling CQ up in the phone portion of the band, and I had about 3 contacts. So it gives you an opportunity to see what the whole band looks like. Next slide. What you see is what you get. The typical filter type rigs only give you a limited amount of view. You can look at 96 kilohertz with some pretty low cost equipment. And then there's some new equipment such as the Hermes Lite, which is actually a DDC radio. There's about maybe 600-700 of those, and it is a software-defined radio. And I can put it on 10 meters, and I hit band scope, and what you're looking at in the lower little slide is 38 megahertz so that's across the HF bands. So I can look and see where there's activity on which band. So I mean, it's kind of hard to do with the KW Atlanta because you're only looking at 2.5 kilohertz. Next slide. Why do it? Well, I like to use my definition of SDR, saying that you're trading in the nuts and bolts for bits and bytes, and it really is a shift from hardware-defined radios to software-defined radios. And the real bonus here is there's so much free software. I guess we lost the screen. Are we going back?
Are you having a problem, Pete? Can you see the
there
screen?
It is. Now I see it. It's back.
Okay.
There we go. It's free software. There's so many software packages out there, and it's just a simple download, which and some of them offer slightly different features. So you get a real opportunity to exercise your radio, and the software is universal. So it doesn't matter what hardware you're fitting it up with. It'll work. And I happen to have a Hermes Lite, and it'll operate with 3 different software packages, and it doesn't know the difference. Now there are variants of software-defined radios, and one of the first, and this was the first foray into this area with Flex Radio, used what's called the IQ, which is a sound card based SDR, which uses the quadrature and an in-phase signal. So you got these 2 signal paths, and they're fed into the sound card, and so it uses a sound card to do the processing. What's more popular now is the DDC, which is direct digital, and now there's even a hybrid. And anybody lucky enough to own the new Yaesu FTDX10 is a hybrid. So it has essentially the software-defined radio on the back end, but it has some analog components on the front end, like a roofing filter and some AGC control. So I guess they got driven to this because people were wanting to have a little more finite control, and they felt with a hybrid approach, it'll give you that. So for $1,700, you can have a FTDX 10, but you can have a software-defined radio spending a lot less money. Now today we're going to talk mostly about the I&Q sound card-based rigs that you can build, and there are 4 elements. You have to have a computer, you have to have a rig, you have to have some software, and you need a sound card. So those are the 4 elements, and as I said, we're going to talk mostly about that. And the DDCs involves a little more hardware, and it's a little more sophisticated. They use these field programmable gate arrays to handle all the signal processing. So these are kind of big devices and add a little more cost to it. But the real answer of why doing it is you have control over the received and transmitted signals so that you can improve the signal quality and information exchange. I mean, I'm so amazed that you'll have a signal quite close to the one that you're trying to listen to, and then just add some digital filtering, that signal's gone. So you really have a tailoring of the parameters and a wider view of the band signals. So those are some of the real benefits and why you would do it. Next slide. So here we have the SDR using the DDC. Essentially, you have a RF amplifier on the front end, which amplifies the signal coming through the antenna, and then the sampling and the digital valuing is done with an analog to digital converter, and then you send that onto the computer where you can store signals, filter it, you manipulate the digital values. Now these tend to be a little more complex and a little more difficult to do from a homebrew perspective. Some of the ADCs are like these 96-pin devices that you can hardly see with a microscope, and so you end up having to be real good at soldering these very large devices onto a board. And it's pretty hard to, unless you have a circuit board, it's pretty hard to do this just using some of the techniques that Steve talked about. Now, the Hermes light is of this form factor of the DDC. Next slide. Here's a picture of a Hermes light. This is a 5-watt rig. It's multi-band, and it operates through a network. So that's a little network switch to the left there. And the thing that's nice about this is you can tuck the Hermes light away in the garage shack where it's like 38 degrees in the morning. And as long as I can connect to that network switch from the home computer in my office where it's nice and toasty, I'm on the air. So this is a new wave here that with my network switch, I can have 4 different operating positions. I could be even out in the patio in the summertime, and just with a small laptop and network connection, there I am on the air. So indeed, this is a lot different than lugging a whole bunch of equipment out to the patio and trying to hook up all the wires. So a laptop with a cable into the network switch, and we're there. Next slide. Now I want to talk, as I said, about the IQ approach. That's the in-phase and the quadrature using the sound card. And really this is kind of back to the future because this uses the phasing approach. And some of the very first sideband rigs were based on using the phasing approach, where you had an audio phase shift network and you did some mixing and you were able to either enhance one sideband or reduce another sideband. And in our IQ SDR transceivers, the signals are really converted to an audio baseband, often called a 0IF. And think of it like a direct conversion receiver, only you have 2 channels. One is in phase and one is quadrature. Now the amount of signal area that you can look at, the bandwidth is set by the sound card. Some of the less expensive sound cards like the StarTech 7.1 or 48 kilohertz. So you can look at about a 48 kilohertz slice. You get some of the real expensive ones and they look at 96, and some of them we look at 192. Now the Hermes light, because it's a DDC, I can look at a single band, 384 kilohertz. So that's like, I can look most of 75 meters. I can certainly look at 60 meters, 40 meters I'm looking at, 20 meters, and so on. A little less there on 15, but you get to see the whole based on where you set how much you're going to look at is set in software. And we're doing, why we build these software-defined radios is because it's doable. Next slide. In terms of what has really happened, the phasing method uses a phase shift technique, as I had mentioned earlier, and it has 2 balance modulators, which eliminate the carrier. And essentially, how you feed those signals 90 degrees out of phase causes one sideband to be enhanced and the other to be reduced. So the mathematicians in the group will sit down there with all the sines and cosines, and then they'll say, okay, this one is reduced and this one is passed through. And then by switching the phase of what goes into your balance modulators, reverses the sideband. So there's nothing really exotic about it. It's all mathematics. Next slide, please. Here is an example of the what we discussed. You have an audio signal, and you split it in 2, so that one leg is in phase and one leg is quadrature, 90 degrees out. And I put those into 2 mixers. And the mixers are like double balance mixers, such as an ADE1 or SBL1 or TUF1, something like that. Then the local oscillator do the same thing, where you put one signal in phase and the other one quadrature. And so you sum those at the outputs, and essentially you have one sideband that's enhanced and the other sideband that's reduced. Well, what's really important about this, think bidirectional. If you pick the right kind of components like the ADE1 or SBL1 or TUF1, these things work in either direction. So if instead of an RF output, I put an RF input and have it through a splitter network, I can reverse that process. So instead of having an audio input, I have an audio output. Next slide. Here's the first look at a block diagram. And essentially, I have a signal on the left coming from a bandpass filter that goes into a splitter combiner. It splits the two signals out at RF into two double balanced mixers. Think of them as direct conversion receivers, and these can be the ADE1, SBL1, Tough One. And then I have a wonderful kit that comes out of the UK from SDR Kits, LLC, which uses an SI570, which is controlled by a computer. And that produces an LO signal at 4 times the operating frequency. And the reason for that is we feed that into a 74 AC74, which is a dual flip-flop, a dual D flip-flop. And what you're able to do is produce 2 signals that are out of phase by 90 degrees. And so these are fed into the double balance mixers, and what results is an I channel and a Q channel. And so I'm able to, and I also included some modem transformers in there because these are direct conversion receivers, essentially, or transmitters, and you get noise issues. So I'm able to produce an I and Q, which is then processed by the sound card. Now what's of note is in the lower bottom there with a big red arrow, this is bidirectional. So in going from left to right in a receive mode, we end up with a receive signal. But going from right to left, I have a transmitted signal. So essentially we have RF, a conversion, and IQ audio. So the IQ audio is either coming out or going in. So you have a basis of a transceiver. Next slide. And this is the hardware. This board is 3 inches by 4 inches. And Steve mentioned I have a CNC machine. Actually, the CNC machine cost me $250,000. And I say that because it was built by my mechanical engineering son, and it cost me $250,000 to send him to engineering school, but the actual CNC is only about $3,000. So I tend to think of this as a very expensive machine. But he presented it to me, and when he graduated and said, "Here, this is for you," he said, "Now we're even." So, okay, we're even. So anyway, up in the upper right-hand corner, you see the 74 AC74, a couple of pots there to adjust the signal levels so that they're balanced. Kind of right in the center, you got the 2 ADE1s. The combiner splitter is nothing more than an FT3743 ferrite core. We've got the 2 modem transformers, and then right smack dab, there is a little relay, because I found out something interesting. When you do the transmit portion, there's actually a sideband inversion. So I flip the I and Q channels on transmit so that the resulting signal coming out so that you receive an upper sideband and you transmit lower sideband. And I subsequently found out after I went and found the innards of the piece of software, I actually could have done that software. There's a little block that you check that says reverse the sideband on transmit, but I found a practical solution with a little relay so that you could do that. And of note here on the left-hand side, you've got 2 3.5 millimeter stereo connectors, which are I and Q, which is the line in, and I and Q line out. And I peeled away the copper foil so that they're isolated, so that we keep the grounds isolated so we don't get the noise into the system. Next slide. Diagrammatically, essentially a little further on the block here, what we have is our 2 ADE1s, which are kind of in the centers, which are the I and Q channel. I use a StarTech 7.1 sound card, which provides line in and line out. The SDR Kits LLC from the UK, wonderful guys. That's controlled by a Raspberry Pi, another amazing product from the UK. Thank God for the Raspberry Pi. 35 bucks and you got an SDR computer. Beautiful. And then the audio input and output into the Raspberry Pi is off a little sound, I think it cost me $6 sound dongle. And then I have the bandpass filters, which is bidirectional. And then I came up with a bidirectional stage using a pair of J310s so that they simulate a dual gate MOSFET. And a couple of relays there switches the ins and outs. Then the linear amplifier is a IRF 510. So not much hardware, and the software is Quisk, Q-U-I-S-K, from N6QW. And like I said, it's a free download, and it's got all this functionality. Next slide. Okay, that junk that you saw on the first or second slide, this is a close-up of the board. Now I've actually built about, maybe a half a dozen of these boards. And this one I've combined a little more stuff right on the board. And you see the two modem transformers, you see the 74AC74. This one happens to have a 40-meter bandpass filter right on it. Behind that is the J310s, which act as a dual gate MOSFET, but it's used as a transmitter, pre-driver, receiver, RF amplifier. And there's two little relays either side of that switch the signal path so that's in line for receive and transmit. And next slide. Here is a whole SDR transceiver shown with the Raspberry Pi, that board, the StarTech sound card. Right smack dab in the center is the SDR kits that has the SI570 in it. Above that, in the center, is the IRF510. To the left of that is a driver, which is a 2N2219. So there you are. It's not shown in the picture is a keyboard and an HDMI monitor. So there it is. That's it. That's the whole transceiver. And I tend to build these for a single band, but there's nothing that says you can't put multiple bands in this and come up with some band switching using the Raspberry Pi to off the GPIO pins to select the correct low-pass filter and bandpass filter. But there it is. That's a breadboard SDR transceiver, and then that later was integrated into a compact assembly that you saw on the second slide. Next slide, please. The real key here is the control panel, and here happens to be the 60-meter band, and it gives you a little more feel for some of the bits, parts, and pieces that you have available to you. You can put a time signal. There's a button with a time signal, so you can step through the various time signals like WWV and then CHU. You can actually hear in Southern California. You have some test frequencies. Also built into this software, this software, which is kind of neat, is under the configuration settings, you can actually look at the sideband signal to see if you really are getting rid of the opposite sideband. So you have the capability of actually reducing the amplitude of the opposite sideband. So, you know, it's the built-in functionality. The other thing that's of real interest in here, you can record with this. Free software, you got a recorder built in. As a matter of fact, a couple of months ago, a guy was trying to test a rig, and he had RF in the rig. And it was very noticeable. And he said, well, I just can't understand. I said, wait a minute. And I said, talk to me for a few minutes. So I recorded him, and then I just played it back. And it was amazing. He says, oh, now I see what you're saying. Yeah, it doesn't sound too good. I said, no, it doesn't sound too good. But the ability to record the other signal is sometimes very useful to help others in the troubleshooting. And so this one is just looking at the spectrum, but you can look at the waterfall as well, and you have quite a few adjustments. If you're a CW operator, this has got some really nice features, like a whole series. When you go to CW, has a whole series of filters, including 200 hertz, 400 hertz, 600, 1K, and I think 1500. So you have a chance to really put some, you know, reduce the bandwidth. So if you're operating a contest or something like that, you have a 200 hertz filter. Go buy a 200 hertz crystal filter and see what that's going to cost you. But it has so much functionality, and it's just really amazing. And some other things you can do is look at your signal. There's some functionality. It's got a band scope on it and what have you. Next slide. Now here, on the very first slide, I showed you a HomebrewSDR transceiver. Now this is looking at the circuits themselves, and a special thank you to Charlie Morris, Z02CTM. Charlie came up with this, and this is a transceiver that's run not with an external computer, but uses a Teensy 3.5, and it plugs into an audio codec board. And it also controls an SI5351. Now this Teensy operates at 120 megahertz, and it's got more memory than a standard Arduino. But the thing is, it's programmed using the Arduino IDE. So you essentially can just go into your Arduino IDE and program the Teensy. Now they've got some new ones, the Teensy 4 and the 4.1. The 4 is a 600 megahertz microcontroller. So when you're looking at doing a lot of fast signal processing, a little hard to do with 16 megahertz, but something running 600 megahertz, you can do that background signal processing and you'll never know the difference. And essentially the main board is right in the center. It looks very similar to the other ones. You'll spot the two modem transformers, the 74 AC74, but in this case, we do not need the SDR Kits LLC because the Teensy provides the control of an SI5351. By the way, I should mention some folks have worked it out so that you can get the signals quadrature direct off the SI5351. So, you know, like clock 0 and clock 1 will produce two 90-degree signals, so you don't need the 74 AC74. So, indeed, it's nice to see how this has moved right along. There's an audio amplifier board. It's got an LM380 in it. There's a bidirectional amp, only this one doesn't have the J310s, but uses a 2N2219, again with the two relays, so that on receive, it's the receiver RF amp, and on transmit, it's the transmit P driver. And then in the back there, you've got the drivers in the front there, right behind the panel. That circuit is similar to the bidirectional amp. There's only one difference as an emitter resistor, so that the driver has a little more oomph to it. It has a much smaller emitter resistor, and then the RF510 in the background. And you can even take that same board, the RF510, and put in one of the Mitsubishi RD 006 HHF1 in there. And the advantage of that is when you get up on 10 and 15 meters, you don't get the signal drop off like you get with an IR510. So indeed, this is an amazing radio. It's selectable upper and lower sideband. Now, it only uses an LCD, but people are working on taking the same basic layout that I've got here and converting the LCD into the spectrum and waterfall display. And there's some people working on that right now. Next slide. Now, the beauty of this all-in-one, as I'd mentioned, there's no external computer. It uses a 600 megahertz microcontroller. Programs with the Arduino IDE. Now, an important note here is you homebrew your own filter or filters. There's a wonderful free software program from Iowa Hill Software that lets you create the Hilbert transforms so that you can make the bandwidth whatever that you want, and it spits out a whole raft of coefficients, and these coefficients are embedded in the software of the Arduino software so that it'll respond to whatever those coefficients are. Now, the Hilbert transforms, we talked about a 90-degree phase shift, and I guess they reasoned that's a little tough to do, 0 and 90, so they came up with a slick idea. They do it minus 45 and plus 45, so the coefficients are based on that degree of phase shift, but the difference is 90 degrees, and that's what's the important thing. Now, the thing is, this particular all-in-one that you just saw on the previous slide does not have a spectrum or waterfall, but there's things in work here, such as there's a new group called the Backpack SDR that essentially takes what you saw in that earlier slide and adds the waterfall and adds the spectrum. So people are working on that right now. And I should also mention, when I heard Steve talk about these various people, and it's amazing because we live in a wonderful hobby. I actually know those people. I know Tim Walford, and in case you're not aware of it, Tim's day job, he raises cattle, and I guess at night he builds radios. So kind of interesting note how you find out things about guys who do things. And of course, Ed Skelton, I never called him man because he goes by Ed on the air, and he came up with a stabilizer, VFO stabilizer circuit using a PIC 16F84. And when I built my Vitx 20, a couple of months after Farhan came out with that rig, it has a VFO stabilizer based on what Ed Skelton came with, EI9GQ. And of course, there's another SDR group that's currently active, and Steve mentioned Cumbria Designs, which happens to be my good friend Ron Taylor, G4GXO, and they've got a group called Eden DSP, where they took a standard soft rock transceiver board, and then Ron developed the software using, I think it's a microchip controller, so that essentially you end up with the SDR. So you might want to visit they're an IO group, Eden DSP, and they're doing some amazing things. So it's a very small world, and you can see, and I happen to know of 3 other people that are actually working on some commercial products that will involve software-defined radios using some of these new devices and chips, like the field programmable gate arrays, and some using the Teensy. So we should expect in 2021 to see some really amazing things come forward. Next slide, please. Now this is what's seen on the internet, and this is essentially it takes a couple of what's called the TALO detectors, and these were a multiplexer chip, and guys figured out how to use these for a receiver and a transmitter, and essentially the blue part is what came off the internet, and I'm suggesting that you could take a Raspberry Pi 3 or 4, the Asus Tinkerboard. You can use software like Linux Mint or Windows 10, the Quisk, audio dongle, HDMI, a monitor, and a keyboard and a mouse, and essentially take what you see in the blue and turn that into a transceiver. So indeed, it's kind of cool. Now, I want to show you something, because while I have the slides in here, plus when they finish up the slides and you're looking just at me, I wanted to show you something because of what Steve mentioned. And there's no reason why you can't build some of this stuff. The circuitry is available. I have a website that you can look up the information. It's also, there's tons of YouTube videos. There's these IO groups that I have mentioned, like the Backpack SDR, and then of course the Eden DSP, and there was another effort called the Micro SDX, and this is another group that essentially is building on the QCX, but they took the QCX board that Steve showed in his presentation, and they're modifying that to operate single sideband. They're still working on it. I happen to have one of those, and I just did not have a lot of success with it, but that doesn't say that in time that they'll get that to work. So again, lots of opportunities, and I guess in recap, next slide, please. The SDR offers many bells and whistles through the software. The hardware is not that complex. If you look at that one board, which is the heart of the SDR transceivers, it's a 3x4 board. It's got a couple of double balance mixers, some modem transformers, one IC, a FT3743, and a couple of pots, and you're just about there. But it's important you take it in small chunks. I have many projects on my websites, and I've presented YouTube videos, and frequently you'll have someone that has never built anything before, and they want to immediately build a software-defined radio. Well, you need to put the training wheels on first and learn how to ride the bicycle before you just jump on the bicycle and say, oh yeah, I can do it. But I think the key issue here is an opportunity for the learning journey, and there are many resources and support groups, and there's the real tilt of the hobby towards software-defined radios. More and more, you see more commercial products. I mean, you see the popularity of the ICOM 7300. I think they got 250,000 of those worldwide, and you know, with a little judicious shopping, you can get those for under $1,000. So indeed, it's been impactful, and the thing is that those radios work, and they work well. But you can build a radio, you can build a software-defined radio. May not be all band, may not have all the bells and whistles that the ICOM 7300, and I'm talking about all the menus, but you'll have something that puts out a respectable signal, and it makes you proud. And the ability to look and see what the band looks like, I think, is I mean, I'll operate an analog radio, and then I'm saying, oh God, I got to tune up and down the band to see if there's anybody on. Whereas I just look at the screen, and I can immediately identify, as I said, go quickly to the FT8 and look at the signals. There's a lot of the FT8 signals, the band's open. So a quick look. Next slide. And I want to thank you for the opportunity to speak about HomebrewSDR. Essentially, we are at a crossroads of the total integration of the computer with ham radio. And I was thinking back to when I first started in this hobby back in 1959. I've been continuous licensed since 1959. My first station was a 6V6 tube on a wooden chassis. And today we have software-defined radios that do all kind of amazing things. And that's just in a span of 60 years. So indeed, it's kind of amazing where it's taken us, and we're operating with a wonderful hobby because there's just so much wonderful technology that enables us to do so much more. And the other thing I think is the way this technology is being developed, it's almost like Lego blocks. You just connect the blocks together. And that's another thing. When I do a lot of building, I tend to build things in modules. And I tend to look at my projects as an experimenter's platform that I can swap out modules and not have to disassemble the whole radio just to make one small change. And there's much to be said for that. Like I'll build what I call a standard audio amplifier, but if I want to try a new IC device or maybe a little different circuit, I don't have to destroy the whole radio just to get that. I unsoldered 4 wires, put a new board in, supply some power, and then I've got a new audio amplifier on the board without destroying it. So there's much to be said for building things in modules. So again, thank you for the opportunity to share a little bit about software-defined radios. Lots of software programs. The Raspberry Pi is an exceptional $35 computer. You can operate with it. It offers so many opportunities. The Quist software does very, very well. For those of you who do not want to use a Linux machine, you can download Quist onto a Windows machine. It will work in Windows. There's another piece of software I use with my Hermes Light called the Open HPSDR, which is a power SDR that I use with the Softrox. And that works only on a Windows machine, but it has some nice features. One of the features that's kind of blows my mind, they got an audio control panel in there, so that even though you are using a a bandwidth of say 2 or 3 kilohertz, you can tailor and tune the audio signals in that 2 or 3 kilohertz. Now let me ask, do you have me on the screen so that they're seeing me as well as the presentation?
We do. We have you quite small though at the moment. We've got one more.
That's okay. That's okay. I just want to show one thing. Okay, what I've got in my hands here is a 16 cubic inch transceiver. But Steve mentioned that the QCX is something you can put in your shirt pocket. This is a project I built 10 years ago, which is a 20-meter single sideband transceiver with a 4-pole filter that fits in your shirt pocket.
It's a big shirt.
It puts out a half a watt. So, and it has 2 crystals in it that are arranged in the VXO, so that the 2 crystals will tune about 60 kilohertz of 20 meters. So you're only limited by your imagination. By the way, for those of you who may have some back issues of QRP quarterly, in the summer, which I think is the issue 7 of 2011, there were 2. I built 2 models of this. This is the smaller of the 2, and there's one that's slightly bigger, has a few more features this doesn't have. But you're just limited by your imagination. So my 20-meter single sideband transceiver will fit in my pocket. So again, thank you for the opportunity to present to the Radio Society of Great Britain.
It's a right pleasure, Peter. We've got one more slide actually, which you gave us, which has got a lot of contact details. So I think we can quickly show that. There we are. There's some of the details there.
So, yeah, I was being funny one day when I came up with the N6QW Radio Genius because I could get it for 99 cents, so I bought it. But that happens to be the SDR site with the documentation, and there's going to be a link in there for this presentation. Now I have a newer one which has quite a few projects, the more current projects. There's quite a few old projects under JES Systems, which I initially started with, and they include some stuff like on boat anchors, like Collins radios, and there's also a refurbishment of an FTDX 100, which was 1967, a hybrid rig produced by Yaesu. This is before they went to the FT101. And then, as I had been mentioning to David the other day, it seems like most hams have second hobbies, and it's either model railroading, photography, music, or cooking. So I have a cooking website, pastapete.com. So if you're interested in some food stuff, I've got my magic secret sauce, which unfortunately I get on my sweatshirt more than I get on the plate. But that is recorded there. So pastapete.com.
Brings a whole new meaning to cookbook, doesn't it?
Yes, it's all homebrew. It's homebrew.
Homebrew. All right, Pete, that's wonderful. Thank you very much indeed. And hope you've enjoyed watching that at home. If you'd like to ask Steve or Pete a question, this is the time to do it if you haven't already done so. You can either ask on the YouTube chat or on the BATC messaging. And please don't forget to include your first name and your call sign if you've got one as well. So let's start with those questions. I think I'm going to go to Steve first, though. Put him on the spot there. Maybe have you got some questions for Pete, Steve?
Just how does he remember all this information? I don't know. Pete and I correspond quite regularly because he helps me out with problems and we share stories and things. So I haven't really got any questions for Pete other than perhaps mentioning. I tend to paint my radios grey. Pete goes for more psychedelic colours, don't you?
Blue. Juliano blue. That's why I got my blue t-shirt on. By the way, you can't see this, but when I clean myself up, I put my special t-shirt on it, and it says, when you know stuff, you can do stuff. So hopefully today we shared some stuff so you can do some stuff.
Yeah, that's very good. Now, we have got some questions actually for you guys, so I'll leave it to you which one of answers it. First one's from Rob Blackwell. He says, cases can be more expensive than the electronic components. So any tips for making cases or cheap suppliers? And we did have a few replies that was on YouTube. But what about you two? What are your favourite cases to use for homebrew equipment?
Well, I have to say, I tend to source mine from radio rallies because you usually find people have bought cases years ago, not used them, and they sell them off for very little money at rallies. And if I'm really stuck, I got some sheets of aluminium and I bash the metal and make my own. But over the years, I've got a collection of various size boxes, and I have to say that they are difficult to come by these days. But if you look around, they're out there. We just had a guy won the construction competition for the QRP club, and his case for his project was a tea bag box from one of the supermarkets. And Charlie Morris that Pete mentioned uses sort of Tupperware plastic containers, which are waterproof as well, which is a different way of working.
Yeah, any tips for you, Pete, for your side of the pond?
Yeah, and actually it should force you to think out of the box. First off, you can construct your cases. Aluminum's kind of expensive, but I have successfully made cases out of PC board. You can buy printed circuit board, and as a matter of fact, one of them, the base plate was a printed circuit board, and I put the copper side up, and I put my IRF 510 right to that copper board. The whole base was the heat sink.
Cool.
It was cool. Yeah, and copper is better. Copper spreader is better. And the front and back, and that PC board will paint up really nice, and then get some aluminum angle stock so that you can stiffen it up so you can build a whole case out of that. The other thing is, and I did this, someone gave me a Vitx 40 that was kind of in sad shape, and I repaired it and fixed it. And I found a really neat case, and this was a case that was intended to house first aid supplies. And it has a handle on it, and it has a gasketed top. So this thing is plastic, so it opens up, and you can put all the hardware in there, and when you close it, it's gasketed, and it's got the carrying handle. So if you're looking for a portable thing with a carrying handle, this is perfect. And I spent $5 for it. So, I mean, that was a lot better than the $35 for some of these cases. And the other thing is, don't overlook aluminum chassis turned upside down. that SDR radio that you saw on the first slide, that's actually a large aluminum chassis that I bought at a bargain closeout, and I just installed it in there, which makes it kind of nice because then you can put a top cover on it and you got a complete enclosure. But think out of the box.
Yeah, and we should share. I mean, when Rob posted that question some time ago on YouTube, we had quite a few people come back. For example, Stuart said for cheap cases, it's often possible to repurpose a case from an equipment that's been discarded. Go around the rummage bins at a rally, he says. Try and find something to repurpose, says Tony Fishpool. Old modems, routers, set-top boxes, CB radios, old sandwich boxes even. An OXO tin. Someone else said, Paul van der Groen said an OXO tin. I'm not sure if they still put OXO in tins. They probably do. Altoids tins, old tobacco tins. So lots of suggestions there. It doesn't have to be the most expensive part of the project, I guess, is what everybody's saying.
Or like Nick Wood has done with a bread box.
Sorry, what was that? A print box?
A bread box.
Bread box. Okay, yeah.
Bread box, yeah, and you can actually find those on Amazon in different colors. He built a radio in a bread box, and the top opens up. Really nice. Really cool.
And I guess we mustn't forget that we are in the 21st century, so 3D printers are now relatively low cost. And even if you don't want to buy one, you can send your design off, can't you, and relatively cheaply get someone to make you it and post it back to you. So that's another possibility. Okay, what other questions do we have here? We've got one thing I was going to actually ask you to, because a lot of people I think are going to be watching this for the first time and looking and considering construction. And some of this just might be a little bit frightening to handle components and to dabble with software and things like that. So would you both recommend that you start with a kit or two?
I certainly would, yeah. When we've been running intermediate training courses and you had to build a project in the past, we found that using a kit was always the best way to go, mainly because it was repeatable. You got all the bits, and it's a good starting point. Some of the kits will actually give you lots of technical information that allow you to understand the circuit more. And as you gain that understanding, you can start modifying and say, well, it came on 80 meters, but I actually want to use it on 40 meters. Which parts do I need to change? And you end up with something that you've invested in. So I would certainly say if you're starting from ground zero, a kit's probably the best thing to do first.
But there has to be a little bit of an admonition there, David. And let me share an example with you. You can find some kits on eBay from China that blow your mind in terms of cost. They have the Pixie radio for $3.72. So this guy buys a Pixie radio for $3.72, solders it up, puts it on the bench, does not connect an antenna to it, and then writes me and says, this thing doesn't work. And I said, well, have you hooked up an antenna? He said, you mean you need an antenna? So the thing is, some of these radios for $3.72, if you've been around the horn a bit, you know enough that it's a single channel crystal radio. Essentially, it's crystal controlled, so you won't hear a whole bunch of, unless there's somebody transmitting on that frequency. But there's some other kits that are a little more elaborate and allow you to tune for like $10. So I mean, it's worth spending. Your first inclination is $3.72. Yeah, go after that. But just think what you're spending. I mean, for about $10, you can get a radio that really works. And don't overlook direct conversion receivers. Direct conversion receivers are a really good place to start. And the reason I say that is I've built several direct conversion receivers that once I got them working, they then got converted almost 100% into a transceiver. So, I mean, that's another thought, is if you can start, do some research on direct conversion receivers, then you have something that's a building block because you know that works, and then you can expand that into other things. And it's not like you throw that away and have to start all over again. So,
Yeah, actually, just on the same subject, although you only answered a few moments ago, James Kelly said you can start with an RTL SDR for a couple of quid and GNU or GNU radio. Yeah?
Yes.
A good way to start with that. A little while ago, I've got to find this question because we're getting quite a few things coming in now. We've got Shirley, KE1L, says, how does the sensitivity of that compare to more typical IQ SDR designs like the soft rock that have gain stages? Now, that was asked around about 30 minutes ago, I think. So that's one for you, Pete.
Okay, since I have both, I have a soft rock and I have the AD1 based IQ. The soft rock uses the FT3253, whatever it is, the Talo detector, and they do have some RF amplification ahead of that. So does the ADE1. Now, you do get a conversion loss with the ADE1, but because I'm using an RF amplifier with the dual gate MOSFET, it has quite a bit of gain. I'd say they're comparable. I'd say they're comparable. Both are comparable. So you do have some preamplification ahead of that. It'll be kind of deaf if you don't have that RF preamplifier ahead of the ADE ones. So that compensates for it. And I don't know if you saw it, but there's a little pot on there. And that was the thing that I liked about the two J310s is I can adjust the front end gain so that's just about right. So you're letting a lot of signal through, but not necessarily a lot of noise. So you have a little opportunity to make some adjustments of how much RF is coming through.
Steve, one for you. I mean, the GQRP club, I know we've given it lots of plugs, but I mean, in all seriousness, it is a wonderful club and extremely low cost to join. And there are lots of these direct conversion receivers and even transceivers, aren't there, which can be made. I mean, they're not quite a kit, but they do tell you most of the things that you need to do to make it.
Yeah, I mean, the club have got two kits. One's a direct conversion receiver, one's a crystal controlled transmitter. And put those two together and you're on the air. They're very much complete in that in fact they use what Pete suggested, that the printed circuit board is the case. So the kit comes with all the parts and the case, so you end up with something that looks pretty good and it works. And the sudden receiver is one of George's most popular designs, I think. We've built dozens and dozens of those at build-a-thons and they work every time. I've got one in what I call my pet rock transceiver, and it's a sudden receiver with a transmitter from one of Drew Diamond's books, and it's brilliant. It just sounds great. And I know Pete's running mate Bill Murray says the direct conversion receiver, you're closer to the signal than you are with a big radio.
Presence. And
it sounds good, it really does. So yeah, they're out there. Tim Walford, he's got direct conversion receiver kits. Kanga do a nice one with a digital display. Lots of them out there, and they really are good to get going.
Yeah, we've been asked actually, Steve, to put some of those links. I know they're mainly UK companies, but we've been asked to put some of those links there. So we'll talk to the RSGB and we'll see if we can get some of those companies mentioned from your talk.
I will certainly send you the links through, and you can put them on the YouTube comments.
Thanks, Pete.
If you would like to hear a simple DCR receiver, check the Pete Juliano N6QW YouTube channel. I have a couple of months ago I uploaded a MC1496. That's a double balance mixer, a Motorola vintage 1980s. And I built a direct conversion receiver. It's got an audio amplifier. It's got a 2N3906 RF amplifier on the front end of that. And then I have an Arduino controlling the frequency. It is stunning. I mean, it is stunning. And that's a direct conversion receiver. If you don't believe me, just listen to the YouTube. It is stunning what that can do. And there's not the MC1496 in a surface mount. You can buy those for like 84 cents. I mean, that's a current build, and that's essentially the receiver. And a 2N3906, you can get it for about 6 cents. So the hardware is not really expensive. And if you want, and I have done this, you can take that and then build a whole transceiver around it. But if you check my YouTube channel, you'll look for the MC1496 direct conversion receiver. Take a listen.
Is that one of the old MC, as in Motorola designs of chips?
Yes.
Yeah. That's been around a long time, isn't it?
Yes, and they're still available in surface mount. It's 84 cents, and I think you can get them at Mouser. Yeah, that's
good, because a lot of those old dual-in-line chips certainly have disappeared now, haven't they? These, Pete, particularly to you, I guess. I'm an old-fashioned sort of electronic designer, really, and I guess because I started a business and I never carried along with the software and the firmware. You clearly started with the traditional hardware of the 60s, 70s, 80s, but you've moved into software. How difficult is it for someone like me who's been brought up on chips and to think of hardware and op amps and that sort of thing? How hard is it for me to get into the sort of software that I'd need to do to develop software-defined radios?
Piece of cake.
Really?
Easy to say. Yeah. Well, okay. The Quist software, the Quist software with the Raspberry Pi is like a hand in a glove. You go to the N6QW Quist software page, and he says load these files. You load about 12 files, and essentially your Raspberry Pi now is set up to go.
Okay. Well, I promise when I get the time, I would definitely give it a try.
Okay. If you look at the N6QW RadioGenius.us, there's a whole series there about loading the software onto the Raspberry Pi, step by step, and what you need to do. So you can look at that first without just saying, oh, what do I need to do? And that'll give you a clue as to what you need to do to set that up.
Yeah, no, we really will. I can't be the only one around who's got a Raspberry Pi and bought it, plugged it in, and then thought, now what do I do with it? So this is a really good advice. Got one final question really from you. This is from Eamon M7CEC, and it says, mine is to Pete. Do you design your own PCBs when cutting on a CNC, or are there designs available that we can download and use on his own CNC? He'd love to build his own using his own tooling.
Okay. I use a program called G-Simple. G-Simple, free software program, G-Simple. And essentially, I use the squares, the island squares. You can actually do it like Eagle. You know, you design a PC board. Eagle takes you out into the woods. I just design my own squares how I want them, and then you create what's called a G-Simple file, GSI. That can be later converted into a DXF file. Then you can use the subsequent conversion from that DX file to do the G code. And then the G code will work on any CNC machine. That's why the code is universal. Now, if he looks up my call in QRZ.com, send me an email. I'll send him a ton of DXF files, which he can convert to G code, and he can have fun with it. As a matter of fact, you're not limited to just making circuit boards. So if you look at my QRZ.com page, you'll see a project that I call the KWM4, where I built a solid-state version of the Collins KWM2. And when you look at that, the front panel looks like a Collins. It's got a black escutcheon, you know, like they normally have with the big knob in the middle. I built that on a CNC. And what's beautiful about it is if I want a second one, I just punch the start button. So it's pretty simple to do using the G-Simple. And if he sends me an email, I'll send him the DXF files of a whole bunch of things that he can try doing that. And the thing that's nice about it is you can import the DXF file into G-Simple. So then you have the design software and you can change it, modify it as you see fit. And just to give you a clue, it's not unusual to take a design, which I start first on a piece like Steve did with the graph paper. I'll lay out all the squares because that gives me the coordinates on the graph paper, what I need to enter into the program. And then once I've got that entered into the program, you can then create all the files that you need and cut the board. Half an hour, typically a half an hour from when I start off with the squares till I got a finished board.
Brilliant. Okay, Steve, any last thoughts?
No, I'd just like to echo what Pete said. Thanks for having us, and I think the two presentations show you different sides of homebrew, but the common core is taking what's available, making something that works, and enjoying it.
Yeah, absolutely, and that's the key of surely the basis of any hobby, to enjoy it as well. So thank you both very, very much indeed. And that almost concludes this Tonight at 8. And thanks once again to our guests, Steve Hartley, G0FUW, and Pete Juliano, N6QW, for showing us how we can get started in radio construction. And if this has inspired you to make something, or maybe you've already made a project over the autumn or during the holiday lockdown periods, then there's just time to enter it into the special RSGB Get on the Air to Care construction competition. Projects can be hardware, software or a system and may be based on a kit. Whether you've just got started or you've been a radio amateur for years, you can enter by just sending a short description of your project, together with a few photos or a video, plus any related circuits or diagrams to this email address that you see at the bottom of your screen, gm.dept@rsgb.org.uk. And please note that the deadline for this competition is the 1st of February 2021, so you've got about 3 weeks. But please bear in mind that the traditional RSGB annual construction competition will also run later in the year, and you'll also be able to enter your project into that as well. Well, we hope you've enjoyed this Tonight at 8 and that you'll join us next time, and we'll be finding out how to start out on the microwave bands. If you'd like to see details of that and any other webinars, or to send any comments or feedback, please visit www.rsgb.org/webinars. But until next time, this is David G7URP signing off and clear. Bye-bye.